So, welcome back. In this module, we are going to see data model in detail. Modeling is one of the most effective techniques for understanding and communicating business rules and processes. Just as an architect creates a blueprint before building a structure, a database designer creates a data model before building a database. Okay. So we have seen a direct comparison of how an architect creates a blueprint before building a structure and how a database designer or data modeler creates a data model before building a database. So modeling is very important, isn't it? A data model is a graphical representation of database that is used to capture an organization's business rule. If you look closer to this data model, you can see there are a lot of business rules and processes and specifications involved in these diagrams. So a data model can be used to define a system's requirement. So from a definition point of view, data model provides a blueprint for building new database or re-engineering legacy systems. Two things data model provides: a blueprint for building a new database or re-engineering legacy systems. Now let's look at the analogy of a model aeroplane and real aeroplane. So what do you see here? A model aeroplane is significantly scaled down version of a real aeroplane. Though it won't fly as a real plane, you will get pretty good idea about the functions and major features of a plane. So similarly, the relationship between our data model and real database. What does it give? This data model gives insight into our data, gives major data subjects, gives attributes of the data subjects, shows the relationship among the data subjects, and shows the business rules for our data. In the data model, it has no data in it, but what it is just a representation of what the data actually is in the real world. So moving on, before you are going to build a ship, if you have visited any shipyards, you can see that they are not straight away going to build one in the mission room as soon as they get a contract. So instead of, they are going to make a blueprint. They make a lot of diagrams, and at some point, once they are satisfied, they will start building it. So our database design or enterprise database structure should be created in such a fashion that first you have to create data model, then you make multiple iterations, then multiple reviews, then once you are satisfied, you can start creating your database. For a data modeler, as he creates your data model, they have to understand the entities, understand the attributes, understand the relationship, and understand business rules. And they should create the real database. Also, you should remember that there are some data modeler tools which can help you generate your database from the physical data model. And that process is called forward engineering. Build the model before the actual build out. Moving on, let's look into what is reverse engineering. This is building the model from the actual build out. Okay, suppose there is no documentation available. You are asked to do a current state assessment, and you know the system is huge. How do you get the details of the database? How possible it is to go through each table, its definition, constraint, indexes, and so on? Of course, it is easy when the database or the organization setup is small. But what if it is a huge enterprise with complex systems? How do you do that? That's where we have this reverse engineering. There are some tools that provides you support for arriving the model from the actual build out. Yeah, getting the model from actual build out is known as reverse engineering. This way, you can get a fair idea of the database when there is no enough documentation. So we have seen forward engineering and reverse engineering. So these are very important concepts in data modeling. Now let's look the value of data model. So the data model gives abstraction from database implementation specifics. As we have already seen that we have different data models, like we have conceptual model, we have logical model, we have physical model. In the conceptual model, we are getting abstraction from the database implementation specific because we don't care about which database we are going to implement your system. It's just giving you abstraction. Again, another value is insight about non-intuitive implementation of the big data storage. So that's another value of having a data model before make the build out.